everything is always posted to functional.tv YouTube channel. Welcome everybody. I'm your host Alexei Krabarov, the founder and organizer of the Reactive Systems Meetup. We started in 2015 after Scale by the Bay conference. The first talk was given by Jonas Bonner, and it was called Life Beyond the Illusion of the Present. And I'm really excited that that image is on the Meetup. It really kind of puts it into a philosophical context, right? It's not just the technology we're talking about ways to write systems. And I think this paradigm becomes even more important as systems are in the cloud. We see a lot of different requirements. We see a lot of, basically it's a distributed system for everyone. Everybody now needs to grapple with distributed systems. And Reactive is basically a way to write these applications, but it's never by itself, right? It's never just, it's a data pipeline. It's connecting different pieces. So what folks are finding that they really need to change the way they think about writing these applications, because if you do it in a legacy context, if you do like a reactive piece, then it just becomes harder for others, right, and doesn't show you much benefit. So what folks are finding, they really need to rethink the way they do this. So in kind of this context, there is a new Linux foundation called Reactive Foundation. It was announced last fall, and basically I'm going to be helping the Reactive Foundation to properly ramp up, and the tagline for it will be Cloud Native Applications Foundation. So if you can think of CNCF as the operator's view of distributed systems and how you basically turn on and off computers in the cloud and connect them, right, and do it fast and kind of in a reliable fashion, Reactive Foundation or CNAF will actually help folks write the applications which run on top of those platforms. So I think Reactive is a core technology, but we're not limiting itself to purely kind of, reactive streams or actors or FRP or React.js. We're not gonna kind of spend a lot of time nitpicking definitions. We really are interested in thoughtful approach to writing cloud applications, and Reactive is, we firmly believe, is one of the best ways we know so far. I think our communities actually have probably the most combined experience, going back decades from Erlang and kind of other things. So I think we're in a very good position with these meetups, especially becoming global. But we also welcome streaming, all right? We also kind of welcome all kinds of ways. How do you think? How do you reason about these things? And so if anybody is interested in kind of advancing this, we'll spend the month of May kind of properly ramping up. Will be some announcement later on, but feel free to reach me if you want to speak, if you have projects, if you have things you want to open source, let me know. So that's the preamble. Also, the logistics, as I mentioned, please ask your questions on Slack. Ryan probably will be checking it as he speaks when he has a good moment for this, and he can take it during the talk. He can defer it until the end. In the end, we'll just have regular Q&A, right? So that's about it. And also, we usually have two talks. Today we have one talk. If you feel empowered to share what you are doing, if you want to lead the discussion, we just had a great chat with Subramaniam Puni about telecom uses of Reactive before we started. If you guys want to continue talking, we'll just open the floor, but also there is a sign-up sheet. It's in the Slack. It's a short URL, basically, listed here. So it's just a Google spreadsheet, and what we could do, we could basically have talks there as a conference format, but we're not on a conference, we're a meetup, so called on Meetup. So if you want to present, just add your talk in there, and we'll review at the end of Ryan's talk if anybody wants to speak, do a lightning talk or lead a discussion. It's pretty open. So with that, I'm very happy to introduce Ryan Michela. He is the lead of the Reactive-gRPC project. He is at Salesforce, which is a great member of our community. And with that, Ryan, take it away. It's all yours.
Hello. All right. Let me get myself sharing. All right. Hello, everybody. So my name is Ryan Michela, and as Alexi introduced, I'm at Salesforce, and I'm going to be talking about Reactive Microservices End-to-End with gRPC. It was a great segue talking about how reactive programming is not something that exists in a vacuum, which is totally true, because one of the challenges I've experienced working with reactive programming is, you have a thing, you build this really beautiful reactive pipeline, but then much like pure functional programming languages, you have to do input and output, and that's where it always breaks down. So gRPC and reactive programming work really well together to build microservices in a purely reactive fashion. So that's what we're going to talk about. All right, so quick show of hands using the little show of hand reaction buttons here in Zoom. How many people are familiar with gRPC? All right, I've got a couple. Fantastic. Now, how about RxJava or Spring Reactor? Yay! All right, we got more for that. I expect that from this crowd. Wonderful. All right, so gRPC is the integration of RxJava, or in this case, or also Spring Reactor, it works for both, and the gRPC remote procedure call system. So a little bit about myself. I am a gRPC practitioner. I use it in my day job. I contribute to it. I own a gRPC Java contrib library, built reactive gRPC, and I'm a strong evangelist of gRPC at Salesforce. I'm also a reactive programming enthusiast, and I enjoy using it. I enjoy talking about it, and I really find it as a very powerful technology for making software easier to understand. So what are we going to cover in this talk? A brief history of microservices at Salesforce, which lays the foundation of why reactive gRPC exists at all. A brief overview then of gRPC and RxJava, but reactive programming in Java in general. Talk about some great demos. I'm going to go deep into the backpressure models involved, because this is reactive programming over the wire. Backpressure gets a little strange, and it's a really interesting topic to get into. And then we're going to end with a really cool demo showing some of the capabilities, compelling capabilities of reactive gRPC and gRPC in general. All right, so where reactive gRPC came from. A little bit of history. Salesforce, it's about a 20-year-old company now, and we've got an enormous monolith, and we've been slowly working on breaking up our monolith over the years. We started in the beginning breaking out microservices and just having them, with bespoke REST APIs, where every interaction was handwritten by a developer on both ends. Every curly brace was negotiated, usually in like Google Docs or something. And we decided we needed something a little more structured. So we went to Apache Thrift. And Thrift gave us a lot of the structure we needed, but at the time, Thrift had some issues involving, port usage and not really having great use for headers. I mean, I know a lot of these things have improved in Thrift over the years, but we saw the opportunity to go with gRPC, and gRPC really improved our capabilities. Additionally, right around the time we started adopting gRPC, we adopted a service mesh technology, and gRPC and meshes go really well together. We've grown that out. We have, I don't even know how many microservices now, but we started with one and now we have many, and it's been a long and fruitful road. So gRPC, a little bit about it. Their headline, they call themselves a high performance open source RPC framework. All those things are in fact true. gRPC is very performant on the wire, mostly because it's on the wire, it's binary. So it's open source, entirely available. All the source code is entirely available, and it is an RPC framework. So unlike REST, which is generally thinking about the world in terms of data structures upon which you can perform 4 operations, gRPC thinks of the world as an unlimited set of operations to be performed on arbitrary data structures. That's really beneficial because it gives you a lot more flexibility and a lot more expressivity in describing how you build a microservice. Under the hood, gRPC is built on protocol buffers and HTTP2. So it's about as standards compliant and rock solid as you can get. The HTTP2 protocol is what it uses on the wire. So it's not special, like say how Thrift was special. And it's protobuf. So it's an HTTP2 message with a binary serialized protobuf under the hood. Protobuf is a really rock solid binary serializer from Google. So the 3 big features of gRPC that made it really compelling for us to use are first that it's contract first. So you start with a protocol buffer's interface definition language specification for a service, and you go backwards and generate all of your language specific stubs. It's polyglot. So gRPC has code generators for 10 native programming languages, first-party languages that come from Google. And there's community support for a number of additional languages on top of that. So we're talking about things like Java, C#, Golang, C++, Python, JavaScript, the list goes on. There's a whole Kotlin's now out there. There's an ever-growing list of gRPC compatible programming languages that you get dynamically generated stubs for based on the protobuf IDL. One of the final really compelling features that we found useful at Salesforce is that gRPC is built on HTTP2, which unlike HTTP1, HTTP2 is a natively streaming protocol. Also starts to make you think in reactive terms when you start thinking about the streaming aspect of it. gRPC has unary and bidirectional streaming capability. So you can make a service that is, instead of a simple one-to-one request response, you can go one-to-many, one-to-many stream. Or I send you a stream, you send me a stream, and we just stream to each other. I can send the server a stream, and then it can send me back a response of how many messages I sent it. There's basically all sorts of possibilities with it. So I know this is a reactive group, and most people here are familiar, but as a quick overview, what is RxJava and reactive programming in general? And as I've come to understand it, it is an API for asynchronous programming with observable streams. Unpacking that, the idea is that everything is a stream. This was one of the, I think, original crazy ideas that made reactive start taking off so many years ago, that everything is a stream. The clicking of your mouse is a stream. The typing on your keys is a stream of keyboard events. Movement is a stream. Even requests coming in off the network can be a stream. Requests coming to a microservice can be a stream. Requests coming in from an RPC request can be a stream. So attached to that stream, we have the idea of filtering, combining, and transforming different operations that you chain together to create a new stream built on the original stream. So as an example, RxJava, for example, has a debounce operator that takes a stream of events and concatenates it over time. So, if the user clicks a mouse too quickly, you don't get every mouse click, you only get one every 10 seconds. Also, you have things like MapReduce, where you can take an object or a message of one kind and transform it into another in a streaming fashion. And then you finally end with subscribing, which is where you introduce an observer, and the observer is what actually looks at the stream. The interesting way that these technologies set up is that you end up designing the stream in code, or you design the pipeline in code, but you don't, unlike imperative code where you write a for loop and the for loop executes as it goes, this is kind of declarative. You declare the structure of your system, of your pipeline, and then when you subscribe to it, events that pass through the pipeline get transformed as they go through. So for example, I've got this little picture here, mouse clicking, and then we want to debounce it so that you don't get too many mouse clicks. we want to map them from mouse click events to robot movement events, and then send that to the robot. And so in traditional Java sense, you would write this and it'd be a for loop, and now keep debouncing the mouse would be terribly complicated because you'd have to keep a timer of every mouse click and how many times something's happened. And then sending that, you'd have to then transform those messages inside your for loop. It'd be gross nested loops and timers and all sorts of stuff. It really just, you end up having the subscribing, transforming, filtering, and all that code blended in with your business logic. It becomes very difficult. But when you put it in terms of reactive, you get something as simple as this, which is just observable, create an event stream from mouse click events, debounce them over a 1 second time unit, map mouse events to robot commands, and then the robot subscribes to that. And every time we get an event, we pass it to the robot.do operator. So we've been able to, with a few lines of code, we've been able to express this very high level concept, and all of the gunk of writing loops and timers and tracking and thread management and all that kind of stuff all just fades away behind a very clean reactive API. So talk about gRPC, and we've talked about reactive programming in RxJava, but what if we brought them together? A stream-based RPC protocol with a stream processing library. Well, this becomes a really powerful combination. So we put together Reactive-gRPC. What Reactive-gRPC is a set of additional stub libraries for gRPC and a protobuf compiler plugin that generates those reactive stubs for Java based on the contents of a protocol buffer's interface definition language specification. Are there any questions so far about just what is Reactive-gRPC and or RxJava, or what kind of at the very highest level? And I'll look in Slack, give you all a couple seconds.
And I guess feel free to my voice if Ryan, if you'd like people to, if you feel like people cannot just ask, feel free to invite people to ask.
Yeah. Go ahead and ask, or ask in Slack. Either one works. All right, I will go on. Oops. Here we go. All right, so let's start with our first little demo. And I'm just going to show some basic gRPC and then compare that to basic Reactive-gRPC. So we're going to see a little bit about the protocol buffer IDL, take a look at the protoc code generator and how that gets wired in a Java project using Maven. For those not familiar with RxJava notation, single T and flowable T is how we describe a stream of exactly one thing or a stream of an open-ended number of things. All right, so, oops, I gotta get to, there we go. So let me bring up our Hello World demo. So starting with the basics, let's look at the protocol buffer specification for this very simple Hello World. So Hello World, what we've got here is protobuf, which allows us to specify the data structures and operations that make up a service. We've got our little greeter service. We have hello request and hello response. They're as trivial as you can be. They're just a data structure with a single string. Over that, we're just describing three operations. One is greet, which is a basic unary operation, receives a hello request, returns a hello response. But now we're starting to get interesting. We can look at multi-greet and stream greet. One receives a hello request and returns back an open-ended number of responses. And streaming actually is a bidirectionally streaming service of requests and responses. So to make that really simple, what we end up having to do is there's this big block of Maven POM, also available for Gradle. You can get this information about how to put this together from the gRPC and Reactive-gRPC sites. But importantly, what we're doing is we are setting up Reactive-gRPC as a protoc plugin, a proto-C plugin for the Proto-C compiler. And so we'll get generated code, generated reactive code for RxJava, and for, in this case, we're telling it we want to do RxGRPC generator, which is going to be the RxJava one. So let's take a look at the basic gRPC service implementation. So gRPC servers are really simple to put together. You basically just create a server builder, give it a port, add a service, and start it. It's very simple from a Java perspective. Implementing our Unary service is also pretty straightforward. You can already start to see some inklings of gRPC's stream-based API coming in under the hood. So we make our Unary response. We're just going to do simple hello world. So we just return on next, and then we complete the response stream, and we're done. If we want to do that with multi, okay, you want to do one-to-many, we can say, take our request, send back multiple responses, and then complete. So that's a stream. But things start to get a little bit weird when you want to do bidirectional streaming. The programming model completely changes. And now what we have is this, we have to return an observer, and it actually like switches the programming model around. It's not nearly as clean. On the client side, if we actually want to make the call, synchronously calling gRPC is incredibly simple. Create a stub, tell it where the server is. In this case, we're not going to use encryption, and we're just going to build it. Create a stub off of that, which is a generated stubs are type safe to the language that they're in. And then we can simply build a request and call our service. But doing blocking is not all that interesting. What we really want to do is asynchronous. And suddenly, once again, the programming model entirely changes. Now, that's not great. So we have to create this response observer. We have to do all these crazy steps, go backwards. We now have to like send messages to our server and indicate completion, and then get responses back, and the response is actually happening in a different part of code. Like, this is the exact kind of like mixing of ideas, mixing of layers of concept between the business logic and the plumbing junk that we're trying to observe, or trying to get rid of by bringing in reactive programming. So if we look at the Rx alternative, suddenly things start to look really familiar. We want to make our service, well, now our service, our Unary service, is simply a function that takes a single of hello request and returns a single of hello response. We can do our simple, what we'd expect. It's map our request to get its name, map the name to a new string, map the string to a response object, and that's the single, that's the stream we're going to return. But now when we have to do multi, or when we have to do fully streaming, like, it's just functions that take singles and return flowables, or functions that take flowables and return flowables. So now we get, basically turns your gRPC service just into your gRPC service is now a composition of reactive operations rather than loops and object management and all that other gobbledygook. Calling it as well, if we look at the async client, is just as straightforward. In our case, we do, we want to call it request. We do, we map the operation. So we actually call the stub, and then we map the response. So we just start with a hello request. We can do the same thing with streaming responses. We map and then subscribe. And we can even do it with bidirectional streaming, where we create a flowable of multiple items, map them to requests, map them through the service, map the response, and then subscribe to the console. So we're able to have a microservice call that's just another stage in a reactive pipeline. So from this little code demo, what we saw was that the hello proto defines the operations and data structures that make up a service. The Proto-C compiler generates Java stubs from the proto during build, and the client and server are build on those generated stubs. The Reactive-gRPC generates RxJava stubs, which are easily extended by the Protoc compiler. And then RxJava makes writing streaming services as simple as chaining together reactive operations. Going back, any more questions? I don't see any in Slack. Does anyone want to ask live?
Yeah, question here. This is Nate.
Yeah.
When you're doing that as stub, is that calling like a factory? Is that a constructor? What is that?
So
does it really matter?
Here we go. It's actually pretty straightforward. Stub, so as is a converter. It's a conversion function. So I think it's in RxJava parlance, I think they call it a lifting function. But the stub itself is just a function that takes in this case, a single of proto request and returns a single, or this one is a flowable of hello response. So as is a function that lift basically allows you to take any function that accepts a stream of one kind of thing and returns a stream of other kinds of thing, and it kind of serves as an adapter between the two.
And that's what the stub actually creates this adapter. Is that what happens?
We're looking at the stub code right here. So this is the generated generated stub code that has this signature that is compatible with come on, out of the way, Slack. Anyway, the signature is compatible with these lifting functions provided by Reactive-gRPC and by Spring Reactor.
Got it. Okay, that makes sense. Thanks.
Yeah, and so that's how we're able to get this continuous flow. And actually, it's pretty neat. In Reactive-gRPC and some of the testing, unit tests, I have tests that show that you can actually chain, because of the chaining nature of this, you can just chain together in a reactive pipeline one call that calls another call, that calls another call, that calls another call. Even even taking into account that a service changes changes the response type, request type to response type. That response type becomes the request type of the next service. It's pretty powerful. And because it's reactive from top to bottom, I'm actually about to jump into backpressure. Reactive-gRPC respects backpressure. So when you chain together multiple microservices calls, particularly streaming ones, the backpressure will stream through all of those in and out calls in order to correctly apply backpressure across the entire stream of the entire pipeline of microservice calls. It's really cool to watch when it, hold on. There, okay. All right, so let's talk about backpressure. So backpressure is how downstream consumers signal to upstream producers to slow down. If you've never seen this, there's this classic episode of I Love Lucy, where what we're seeing is a little clip from it. In this episode of Lucy, she's responsible for packaging up these little candies as they come down the conveyor belt. Everything starts out fine, and she's able to keep up. But the conveyor belt keeps going faster and faster, and more candies keep coming down the line. And suddenly, she has no way of signaling to the upstream producer to slow down. Chaos starts to ensue. If this is in your code, this is how you get out of memory errors. This is how you get thread block. This is how you get all sorts of crazy things that start piling up in your code, and you end up with all sorts of breakdown because there's no way for the consumer to signal to the producer, hey, back off, stop sending me messages, let me deal with what I have. All right. So in Reactive-gRPC, we end up having 3 different backpressure strategies working together. On the wire, there's HTTP2 providing backpressure. Then there's gRPC, which is providing gRPC's internal implementation of Backpressure. And on top of that, we end up having RxJava or Spring Reactor with their own independent backpressure implementations. And all three of these have to work together and are coordinated by Reactive-gRPC. I'll mention producer and consumer. Normally, when you're thinking about microservices, you think, client and server, but client and server don't necessarily make sense because the stream might actually be flowing from the server to the client or from the client to the server. So we'll just use producer and consumer to keep the nomenclature straightforward. So at the HTTP2 level, backpressure is stream-based. So flow control is based on streams of bytes, not messages. And multiple streams can exist within the same HTTP2 connection, and they're all multiplexed together. So with HTTP2, it starts with an initial what's called a flow control window, which is negotiated with the connection is established. The default's around 65,000 bytes. And what happens is both the producer and consumer are keeping track of the size of this window. And so the producer will send bytes until it's exhausted the width of that window, in which case it will preemptively stop sending data. The consumer is reading those bytes off and from its queues. And when the consumer is ready for more, it sends a window update event asking for more bytes by expanding the size of the window. And so the producer will go back and forth. The producer will send bytes until the window is exhausted. The consumer will update the size of the window, which then triggers the producer to send more bytes. It's a very straightforward, just back and forth protocol. But remember, this is just bytes. It has no concept of messages. It has no concept of request or response objects. And it has no concept of things in Java. Now, built on top of HTTP2 is gRPC. And gRPC is message-based. It deals with serialized protocol buffers, buffer objects. So on the producer side, there's something called an onReady handler buried deep inside gRPC. And its job is to serialize protocol buffer messages into binary streams and hand them off to HTTP2 up until the flow control window is exhausted. When that happens, backpressure kicks in and the onReady handler loop gets closed down. When a window update is received by the HTTP2 layer, that triggers the onReady handler's triggers the onReady handler to start its loop back up, and it will keep going, doing its loop of serializing messages and putting them into the HTTP2 send buffer up until the flow control window is exhausted again. On the consuming side, we have gRPC, part of the gRPC consumer stack. It's calling request. So a service consumer ends up calling request 1 or request 2 or whatever from the underlying gRPC, the underlying HTTP2. And this results in deserializing a protocol buffer message when enough bytes have been received and giving that to the service. So consumer calls request, gRPC, then request 1, the gRPC machinery then deserialize a message and calls the services on next. So you on the consumer side, you end up with this loop of request 1, get a message, request 1, get a message, which looks a lot like what you see from other reactives. And then at the RxJava level, these are message-based flow controls over Java method invocations rather than over byte streams on the wire. So consumers call request 1, which passes through the operator chain, delegating down request 1, request 1, request 1, all the way down to the producer, which then produces a message. Producer calls on next, which propagates back up through the chain, and all of the intermediate operators have their opportunity to do what they need to do, whether it's mapping, reducing, debouncing, whatever, all of that happening through the mediation of these requests and on next. Obviously, RxJava and Spring Reactor are dramatically more complicated under the hood, but this is the basic gist of it. Now, when you pile all three of these different flow control technologies on top of each other, they have to make them all interact. And what ends up working with Reactive gRPC is that it's not one flow control system from end to end. Like, it presents itself as that because it's reactive on the client and reactive on the server. And you'd think, if I call on next one on the client, I'm going to get the server is going to produce one message for me. But that's not exactly true. What you have is this loop over here on the left, which is on the producer side, where the part in orange is kind of the active part that's driving this loop. The gRPC onReady handler is pulling through the reactive stack to pull the reactive pipeline, pulling messages out and putting them into HTTP2's send buffer up until the flow control window closes. On the other side, you've got your reactive observer, which is pulling messages up from gRPC, requesting one, and then getting a message deserialized from the receiving side's HTTP buffers. And on the middle, over the wire, is this binary flow control system opening up a flow control window to request more messages. The result is 3 different flow control systems all interacting with each other. It appears to be one consistent flow from end to end, but it's actually a little more subtle than that. Any questions about how Reactive gRPC, gRPC, or HTTP2 work in their interaction with flow control and backpressure?
I think we have a question on the Slack, Ryan.
Yeah, looking a decent observability tool. Can you clarify about that? I do have a demonstration, which will come up next, which is actually seeing backpressure live. So if that's what you're asking, I'll show that. That's pretty cool. All right, wonderful. So this little demo here is going to show show a little program. We're going to have the slow producer. So the slow consumer. The consumer is going to be the light orange line. It's got all it does is read a message from gRPC through Reactive, and it's got a delay in it, so it just sleeps a couple of milliseconds. I think like 100 milliseconds between every message. The producer, on the other hand, is fast. It's going to crank out messages as fast as it possibly can. All right, so let's take a look at this. When we let this thing run, there it goes. All right, the consumer is the light orange line on the bottom that's consuming at a pretty regular rate. You can see the jumping of the producer side. Every time the producer jumps is when an HTTP flow control window gets opened. So when HTTP2 requests more bytes, and that causes the producing side of Reactive to spin up and basically produce as much as it can, as quickly as it can, up until it fills up the HTTP2 buffers and HTTP2 pauses. On the gRPC consumer side, it's pulling messages at a constant rate out of those buffers. Let's see, if we go and take a look at some of the code for that, that demo is the backpressure demo. So we come here, backpressure controller. All right, so this is actually a gRPC service. What we're doing is a little proto, send numbers is all it does. So it's a service that is told how many to return, and then it returns a stream of number objects. And so let's see if I can find the quickly produce numbers. Okay. So there's a gRPC server in here. This is oh, right. This is what actually subscribes. When I click that button, this is what happens. We reset the graph. Then we're going to create a single of 5,000. This is where we're going to tell the this is on the client side. Map that to a number or a number request. We're going to send it, which is going to call that send numbers API. We're going to map the results. Here we're doing a very simple zip with a delay of 3 milliseconds in this case. This is just forcing the subscription and the consumption of messages coming through that zip width to wait for a 3 millisecond delay. And then leveraging one of the benefits of Reactive, we can switch our thread context over to the Java FX scheduler, and then we're going to subscribe by updating the UI and adding a point to our graph. On the producer side, so this is, where are we overriding? We are overriding send numbers, here we go, from our stub, because our controller actually implements the service itself. Yeah, there we go. Implements or extends our Backpressure demo service implementation base. On the sending side, we're going to split a simple flowable of numbers. Basically, we've been asked how many we're going to return in our service. So we're going to map how many, where do we get, sorry, it's been all right. So yeah, we end up forking it and returning. So, all right. Yes, we process the request, map from publisher. There we go, that's what it is. So we're just doing a simple flat map. So we receive a request from the client, and the client is the UI in this case. We receive it, we extract out, we map the number to get the number. So we extract out the value that was requested. We flat map that into a new publisher for a range. So this allows us to basically, produce 5,000 messages. And we're going to do that as fast as possible because you can tell there's no governor in here slowing it down. And we're going to split that with a share, and then we're going to observe it on one side to update the UI while also returning the results back via this service call. The request, someone was asking, being new to gRPC, the network traffic. The network traffic is actually going to be less chatty than REST because it's binary serialized protobuf over the wire. So all of the metadata about the structure of the message is thrown away. All right, so going back to our demo, the important point is that the producer side of it here is producing as fast as possible. The consuming side of it has a delay built in, and we're not buffering, or well, we're not buffering for infinitely. If the producer was producing as fast as it could and the consumer was consuming at a slow rate and there was no back pressure, these two lines would just continue to diverge. But the fact that the producer is being stair-stepped like this is showing that back pressure is being pushed all the way over the wire from the consumer through the gRPC stack, down over HTTP2, up through the producer's gRPC stack, and then up through the producer's RxJava to the RxJava subscription, and pushing that back pressure all the way from one end of the wire all the way to the other. And this is using the network stack under the hood. It is actually passing through TCP. If I can find that code. Doing initialize, there's a stub and there's a port. Yeah, we're building a port on 9000. So this is actually, even though it's all in the same process, it is doing a full out to the network stack and back. Just to demonstrate there's no hand waving. We really are serializing messages over the wire and getting back pressure from end to end. Oh, all right, so questions so far. There was a question about chattiness. In that case, chattiness is really based on how you design your API. You can make very chatty APIs with very small gets and sets, or you can make very chunky APIs with very complex operations, sending large complex data structures back and forth. It's really up to you. gRPC does lend itself to building really like APIs that are the right size for what you need to do, not rather than forcing you to build a chatty API like you get with REST. Any more questions? Anyone got anything they want to ask over the Zoom?
Yeah, flat map publisher, what does that do in simple terms?
Flat map publisher, that's this right here. Pretty straight, the simplest thing that it does is it takes an input. In this case, the input is of, here we go, we can look at that. It is a function that extends, or sorry. In simple terms, what it ends up doing is it takes, for every message that comes in through the input side, it's going to create, it's going to concatenate together the results of a publisher. So what are we doing here? This statement here says, given a number, I want to return a flowable.range, which makes a stream of, in this case, integers from 0 to I. We're then going to flat map that, which means that if we were to do this over again, let's say we did 1 to 5, we could end up getting something like 1, 2, 3, 4, 5, then it resets, and the next iteration goes 1, 2, 3, 4, 5, and then it concatenates the next one, 1, 2, 3, 4, 5. Does that make sense? So every input
the map
number, go ahead.
Produces a series of numbers in this flowable range.
Yes, and so
it's like a not a single object, but like a flowable type.
Exactly.
Construct.
So
okay,
one input message produces many, well, one or more output messages, and it basically produces, the resultant stream is a stream of those streams, all concatenated together end to end.
Yeah, that makes sense. Okay, cool, thanks.
Yeah. All right, so let's look at our last really neat demo, which is applying Reactive-gRPC in a bunch of different ways. Got a little IRC chat-like application that I built. It has three different user interfaces: command line, Java FX, and Android. All three of them are using Reactive-gRPC and gRPC, just to demonstrate how this technology can be used in a lot of different contexts. The basic architecture is three different types of UIs, all interacting with the server. There's two RPCs. One is to send a chat message to the server, and you get back nothing. And the other is to subscribe to an endless stream of messages. So this is a new way, kind of the new reactive way of thinking about an API, is that I'm subscribing to an endless stream of messages rather than having the server, rather than polling the service, is there anything new, is there anything new? I'm just going to subscribe, and the server is going to push messages down. All right. So let's look at this. Let me start up my server here. This is a simple Spring Boot server running on gRPC port quad 9. My Java client's going to start up. And I'm going to start my Java FX UI, which is probably, oh, perfect. And I can start chatting between them. You can see we're communicating. Okay. And then if we come here on my little Android simulator, come on, there we go. If all works. Yes, all right, they're all chatting with each other. Wonderful. Okay. So three different platforms: mobile, desktop, server, and command line, all working together using reactive technology. If we look at the code for this, like it becomes really pretty simple. So Backpressure demo. The server, not one. The server is that's the gRPC server side. Very straightforward. Just create a server, start it, put it on a port. The service itself is almost trivial. We're going to use something, RxJava construct called a publish subject, which is a thing that can be published to and subscribed to. So it ends up working as a pub sub bus in our case here. Our posting message side is as simple as broadcasting a message. So this is when the users post a message, we're going to broadcast our message. So put our message onto the broadcast pub sub. And then we're going to write out a log message, and we're just going to return an empty. So we create this pipeline that's going to do that piece of work whenever a message comes in. And when a client calls get message and starts to subscribe, it's as simple as subscribing to that broadcast and returning that subscription back to gRPC. So now, anytime a message is put onto broadcast, the streaming gRPC service is subscribing to those changes and pushing those changes out to the clients. Now, if we look at, here we go, console Java, this is where the real power of Reactive starts to shine, is that the key code of subscribing to incoming messages and writing them out to the UI, publishing messages, so every time all we're going to do is observable. We're going to then create a stream that starts with the words so-and-so, name joined, and then continues with a concatenation of listening to this iterable, which is going to pull from the console. So what I did is I made a little helper class that just creates an iterator that reads from the console over and over again. And so we can just subscribe to that open-ended iterable, and that becomes our stream. Our stream is just this continuing stream. And then finally, when that stream ends, because the user types quit, we'll concatenate with it left, message that says the user left. We're going to transform those strings into gRPC messages. We're going to flat map them, so we're going to transform them to the actual sending of the message. And then lastly, if there's any errors, we're going to subscribe, and if there's any errors, we'll print them out. So we've just made a stream that just starts with thinking about a chat program as a stream of chat messages that get published to the server through this gRPC call right here. On the receiving side, we're also going to create one where we call, we're going to start with an empty, because it doesn't matter what the input is, that gets, where we subscribe to the server, to its get message stream. If you remember, that's the one that's being pushed to us. Filter the ones out that aren't ourselves, and then print them to the console. So we've set up, instead of having a chat application made up of a whole bunch of loops and flow control and whatnot, we've redefined chat as a stream of messages going from the key, a stream of strings transformed into messages and published out through a microservice, and then a stream of strings coming from a microservice and printed to the console. If we look at the Java FX client as well, it's a little different because we're binding to the Java FX API instead of the console, but it's basically the exact same pattern. We have a stream of incoming messages. which we're going to subscribe. I mean, we can subscribe on the IO scheduler, and then we're going to pull those messages, and we're going to call the service and subscribe to its result stream. From that, we're going to pull out the message, and from the message stream that we get out, we're going to subscribe by putting those messages into the text box. On the sending side, we have a stream of button clicks in our case, which is clicking that send button there in the UI. Well, that button becomes a stream of button clicks that we then map the button clicks through a function that gets the text from the text box, map those strings into messages, pipe those messages through the microservice through the service that sends the message to the server, and then we just subscribe, and when we get a response back from that, we clear the text box. Arrival and departure messages is similar. So once again, we've rethought a user interface as in terms of stream of events coming from the server that make modifications to the UI, and a stream of UI events that then get mapped to microservice requests and sent to a service. And then finally, when you switch over and do this in Android, you know, RxJava, Reactive-gRPC, and gRPC all work in the Android ecosystem. So we have the exact same thing, subscribing to incoming messages by turning the messages from the server into a stream of messages that we observe on a particular scheduler, and then subscribe to the results, and in this case, push them out into the user interface of Android. And on the publishing side, we have a stream of click events from the Android UI that we observe through, map those click events to pull out information from the user interface, convert those into requests, send them out into the across the service, and then when we get a response back from that, we clear the text box. So the same pattern of recasting how we think about complex iteration into stream processing on a stream of events works across all these three different platforms. And it's the same API, it's the same technology, whether you're in console, server, desktop application, or mobile. It's a really powerful paradigm. It's a great way of thinking about building software. So that's what we saw. Reactive-gRPC making a chat server basically trivial to write, working on command line, Java FX, and Android. So to conclude, what we have is that gRPC makes microservices really easy. Starting with the proto-IDL, which is the single source of truth for your service, we're able to generate code across many different platforms and use a technology that works across all different operating environments. We bring in RxJava, which is a different way of thinking, reactive, RxJava, or Spring Reactor. We think of recast the whole world as a stream of events. And when we have a stream of events, we can now think in terms of function composition rather than iteration and if and then and else. So Reactive-gRPC bridges these technologies together. It makes sure that flow control works end to end and automatically pushes Backpressure from producer to consumer, even across the wire. So why do you want to use Reactive-gRPC? The technology is asynchronous by default. Everything from top to bottom is async. So you never have to worry about that async to synchronous impedance mismatch where you're secretly blocking on something that you didn't know about. It gives you a unified programming model across multiple different platforms. It gives you a simplified programming model. All of that iteration, all those loops and nesting all gets just turned into a simple stream of operations concatenated together through function composition. So gross code like this on the right to call a service turns into very simple code that allows you to do multiple service calls and chain the results. The output of one just becomes the input to the next. And finally, it gives you a consistent programming model. How you write code on mobile is the same way you write code for the desktop, which is the same way you write code for the server. It's a very powerful system. So yeah, desktop, mobile, mobile and console all work exactly the same. Well, that's my presentation. I appreciate you all taking time to come out and listen to it. For resources, I encourage you to check out grpc.io, which is the home of gRPC, Reactive-X, home of reactive programming. It's of all different kinds. Particularly, you can find links to RxJava and Spring Reactor from there. This project is Salesforce Reactive-gRPC, and you can also find all of the demo code you saw today, as well as the main library itself. If you'd love to help out, I would love your help. Things I need the most help with. Spring Reactor has a context propagation API that I still have yet to wrap my head around. I've tried a couple of times, but there's some subtle reactor context propagation bugs I just haven't been able to fix. So if you're an expert in Spring Reactor context propagation, I would absolutely love your help. Otherwise, porting to other languages, there's been asked for a C# implementation. Obviously, that's an enormous lift, but it'd be really cool to have one. And there's also RxJava 3 recently came out, and maybe it'd be worthwhile to write bindings for RxJava 3. Any final questions?
I had a quick question.
Yes.
So, yeah, so with the client, the example that you have with the chat, for instance, so since those, the gRPC endpoints there, they were, I guess they're bidirectional streaming. So in that case, the client just has one, it's just one, I guess, connection. Does it like, is gRPC with HTTP2 like suitable for just like a long-lasting bidirectional stream for the whole session?
Generally, yes. So gRPC, so HTTP2, so it is a bidirectional multiplexed streaming protocol. It is suitable for long-lived connections. Now, you do have to take into account that long-lived connections over the open internet are naturally unreliable. Reactive-gRPC does have some retry capabilities built into it to allow you to put a retry operator in place so that should the stream drop because the underlying connection was severed, it will continue to basically tell gRPC reconnect and reattempt the stream. So it'll send the connection, the request again, and subscribe to the stream. That doesn't always work on, that semantic doesn't always apply. If you've got something complicated, like I need to send, a stream of requests and get a stream of responses. So you may have to do some stream connection renegotiation logic, which is actually pretty common in most gRPC applications that deal with long-lived streams. But that kind of thing, that kind of code kind of lives in the user space because it's really hard to, it's very application specific as to how you want to do your stream renegotiation.
Sure. Thank you.
Question about RSocket. Yes, I am familiar with RSocket. It is different than gRPC. So I'm not here to make a stand as to which is better. They both have their place. I know about RSocket, and it is a very cool technology. If anyone's interested in porting Reactive-gRPC to Reactive, well, actually Reactive RSocket is, because RSocket is natively reactive, so never mind. But if you're interacting with something that's gRPC based and you want to do reactive, this is a technology that can help you.
Hey, I had a question, but I think it got swamped before in the chat. So, can you elaborate on the use cases for Reactive-gRPC you use at Salesforce? And
sure.
Yeah, and if it impacted you, I mean, it doesn't have to be necessarily positive because I've seen resistance to reactive programming as well. But if you have a positive feedback and metrics you can share, that can be great.
I'd love to share that. I am not aware of anyone at Salesforce who has actually adopted Reactive-gRPC. As much as I'd love to be, getting, as you said, getting reactive programming in into an organization can be very challenging. I am aware of other companies out there who are using Reactive-gRPC. I believe they're using it successfully because they're building some pretty some big applications on it. But yeah, I can't really, no one at Salesforce is using it that I'm aware of.
All right, thanks.
Yeah, getting an organization to adopt reactive technology is a whole nother presentation.
Yeah, I know that.
I had another question actually. I was wondering if, in terms of like performance, if you saw any, I guess, like performance hit by relying on RxJava instead of just using the, you know, what gRPC Java comes with. With our company, for instance, we tried to do something similar with for Akka streams in Scala, but we found that there was a performance hit when, at least with our implementation with Akka streams. And so I was just wondering, like, in terms of your benchmarks, if you saw any tax. Yeah.
We do have a benchmark project, and if I pull up the main repo, open reset. We do actually have a, where is it? Somewhere in here is benchmarks, not under interop. No. Where, I forget where the benchmarks are, but we did do some benchmarking. I don't recall there being a dramatic difference between Reactive-gRPC and raw native gRPC. The majority of your latency is going to be in the network. So if you're adding a couple of, you know, if you're adding a small amount of latency in process, I don't recall there being any real major performance hits. Ah, there they are, benchmarks. Yeah, we do have we do run the same set of benchmark tests that gRPC runs. And so our comparison, it wasn't significantly different.
If I may, I could add one or two things here. So when we have written RxJava 2 and Reactor a few years ago, they came from a same project we called Reactive Streams Common. We tried to make sure that it was the least impacting on the performances, when we always compared with normal sequential programming, so a for loop, for instance, compared to a flat map. And we try to avoid a lot of allocation, a lot of volatile, touching volatiles and queues. If we can, we have some kind of internal optimization inside these reactive libraries to avoid creating queues when not necessary, because as soon as you have an asynchronous boundary, most of the time you need a queue for message passing. And we try to do all of this optimization. It unfortunately made the code for Rx and Reactor pretty difficult to read if you want to dive into that and help, you know, with issues. But the trade-off was to minimize the difference, the gap with programming just the usual way without, you know, using any functional types. The other thing I would say is, if you, so the overhead is pretty minimal, but if you want to use the reactive stuff with something with latency like gRPC, I think that's at this point very negligible. Like you never see any gap, because that's not the operation, and the cost of this operation that will take any time. That's a network latency or your operation latency. And maybe I will add a third point, which is it's not necessarily making things faster using a reactive library or reactive end-to-end. It's first and foremost to make things scalable and more efficient. That doesn't mean that you will do like a better request per second throughput. That means like something more like resource utilization. If you are busy doing something, you're not forcing your system to do nothing until you finish with this thing you're doing. With the concurrency you gain by using the reactive libraries, you can utilize more of your resources. And at the end of the day, that means you're saving maybe more instances, or you running your system on less instances in your cloud, and that that equate to something at some point. That's why I was pretty interested in if there was a use case for Reactive-gRPC at Salesforce, because that's the kind of point of view from companies, the traditional reason for adopting reactive libraries to make system more efficient, so they cost less to operate.
All right, well, if there's no more questions, I will hand it back to Alexei.
All right, guys, thank you very much. That was really a good talk, and I think we have a lively discussion in the Slack. So my question basically would be, if folks are interested in more kind of open general discussion, if you guys, so Stefan basically led us into this. If anybody wants to share kind of experiences modernizing your company with this, basically it's all yours, right? So I just wanted to see. One request I have, if you want to speak, please, if you can turn on your video, that would be, easier, I think, on folks to see somebody making their points. Also, it's easier to identify who it is speaking, because Zoom makes it hard to find out otherwise. So the floor is yours. I shared the sign up sheet for the Meetup. Nobody sign up yet, so this is all good. We're kind of trying different ways. What another experience I heard, that folks like to kind of do hallway conversations with each other. Slack can allow this, right? They can chat with each other one-on-one. But unfortunately in this Zoom, we can kind of generally do mostly the main talk. So, but if anybody wants to share anything right now, please say so, as they say in the waiting, or forever hold your peace. Let's see. One question I have for everyone: if you guys maybe raise your hand, who thinks that 5 p.m. is a better starting time than 6 p.m.? That would be really helpful. If you guys can do that. Okay, I see some hands. Okay. And who thinks that 6 p.m., the old standard starting time, is better? Who would rather do 6? Okay. Fewer hands, I see. And one more question I want to ask. So since we're now a global meetup, we have a lot of folks who want to join from Europe. And in order to let them easily join, we really have to start early. So if we're on Pacific Coast, we can do a 10 a.m. or 11 a.m. So for those of you who are kind of doing enterprise Zooms, I'm not really sure what's happening in the world kind of work from home. So if you think that you can do a 10 a.m. or 11 a.m. meetup as an attendee, if that actually works for you. I mean, we can do noon, which becomes lunchtime in the US on the Pacific Coast, kind of 3, you know, on East Coast. So I wonder if that works. So if you can raise your hand, if you can do a morning meetup, if it would be okay with you. That way we can, you know, invite Europeans to present. Okay, Ryan is for it. Anybody else? Raise your hand if you cannot do this. If 10 a.m. or 11 then absolutely doesn't work, it's not a good idea for you. You're all like in work stand-ups and Zooms or whatever. It's okay. Nobody says it's not possible. All right, cool. Okay, one. Okay, Solaris says thumbs up. I don't know if this is like he cannot do it or he can do it. I'll ask you, Solaris, later. All right, so I don't think we have any more immediate talk proposals. So what I encourage you guys, please let me know. We are really ramping this up. I'll be focusing a lot on the reactive technologies in conjunction with everything else. So please let me know if you want to give talks about it in various spaces, in various domains. For instance, telco, as we heard before, how it enables other things like machine learning, streaming, you know, streaming data analysis, everything goes. IoT is perfect. Let me know. Thanks everybody again for joining. I'm really excited about this. And thanks again to Ryan for the great talk and the great presentation. Thank you, guys. If nothing else, see you later.